This is another video on my quadruped robotic controller, and the first one featuring the Biddle, which runs on an ESP32 microcontroller, which I have written 100% of the software for in C++. This project started with the Spot Micro, which is an open source quadruped robot you can download off the project website. And while it comes with some really great out-of-the-box software, I wrote 100% of the software for that as well. For my project, which I have featured on my YouTube, walking around this desk. It works really, really well, but it had a few problems in that there was a lot of play in the joints, probably like 20 degrees of slop in the joints, and the range of motion of the limbs was not very impressive. To solve those two problems, I set out to build my own from scratch in Fusion 360. Which is a work in progress here, and like I said, has a different leg design to try and solve the problems I mentioned earlier. The problem with this being a work in progress is that I can't test out any software on it until it's done being built, which is why I purchased this Bittle, which is a really well-made hobby-grade quadruped that, as I mentioned, runs on an ESP32, and eventually I can put the same board in any of these robots. And as long as I change the math for the length of the limbs, everything should work the same across all platforms, which is really the goal. Here, I wrote everything again from scratch in C++, from the servo controls to the inverse kinematics for the limbs to the communication protocol, which is allowing it to communicate with the Quest 3 that I'm wearing and has its pass-through turned on so that I can see my digital twin models and even overlay my models with the real thing. There's going to be a much better example of that shortly, but I need to connect to the quadruped first. So what is happening right now is the Biddle is just broadcasting a connection message out over my Wi-Fi network, waiting for something to connect to it, which we are going to do now. This will work. It's out of the box Unity button. Probably needs a little bit of work. There she goes. So now on the left, the red quadruped is a digital twin that's running on physics. It's moving right now, unfortunately, but that will stop. When the real one connects, my quadruped is going to stand up, and its digital twin is going to match its position, which usually is pretty quick unless I'm trying to record a video. Yeah, so that took a little bit longer than normal, but it has connected. And so you can see here that this digital twin, its only job is to represent the real life quadruped. This is sending information to the ground control, which is the headset software, telling it the angles of the legs. And now I can confirm that those are 100% correct. There is a perfect overlay in my digital twin with the real Biddle, which is an excellent use of this AR pass-through technology, is verification that your software digital twin is an accurate representation of the real thing. I could leave it there, but it's easier for me to understand what's happening when I can see the both of them. So over here, the red version is the Biddle that is running its own physics. This is all built in Unity, and Unity is built on NVIDIA's PhysX system, which for these hobby-grade projects is more than enough to simulate my software. I have another video of a simulator of this, and I test out all my walking gaits on a simulator, a physics-based simulator, before I send it to the real thing. Another thing is that there's a gyroscope in here, and that's all hooked up. It's not transmitting that information right now. If it were, I would pick this up, and this version would move around as well. One of the ideas of this project is that if this digital twin on the left is accurate enough, I don't need any sensors on here. If I lift up the two front legs, this physics version should tilt forward, representing what's happening in real life and eliminating the need for any kind of sensors on board. As you'll see in a second, we are a little bit far away from that happening yet, but it's a work in progress. So up top here is and it shouldn't be overlapped with the UI, but it is because it moved a little bit. But this is the actual controller. So these are the IK targets, the inverse kinematic targets, and this is what I manipulate with code. This is the true source of everything. I only interact with this, and it sends its servo positions to the digital model, and then through the network to this, and then it's mirrored there. So anytime I want to write a walking code, I move this box around, inverse kinematics moves this leg, and then that is sent to these two robots. So let's see that in action. Again, I can overlay these two and watch it, but I'm just going to leave this guy here. So let's try the high step here. Great. So now they're all moving. The code is actually being run on this. You can see the limbs one at a time lifting up and going back down. And now the commands, after I move this box, the servos move, and these guys move with it. So what's happening here? The physics version is running the code. The real one is running the code. And this one is mimicking what the real one is doing. And now what I can see is that it's working pretty well. I have the high step moving quickly, but you can tell that when it lifts its foot up, it starts to fall in that direction. And when I have the movement slower, essentially, if you were to lift up one of these legs, the Biddle would tip in that direction. But my physics simulation doesn't represent that. When you lift up a leg, the other three are able to support it. And that's not an accurate representation of the real thing, and represents a problem in my physics digital twin. I need it so that when I lift up one of these legs, it begins to fall in the same manner that this does. The reason this one falls is I think the servos are not powerful enough, despite the center of mass being between the three legs and the weights all being the same. I think it's the servos. The three servos are not strong enough to hold it. And so that's why this one starts to tip and the physics one doesn't. But again, now I can overlay these and watch the legs go one at a time. And tell that all of my digital twins, with the exception of it rocking the way it should in real life, are fairly accurate. And so now I can continue to build out the walking software and test it on this one before sending it to this. So that is the next step. But as far as this goes, I'm very pleased with it and couldn't be happier with this overlay and what a good use case it is for this type of technology. So I'll continue to keep posting some updates. Hopefully I'll have the code up sooner or later. The code for this is on my GitHub already. But without the ground control of Quest headset software, it won't do much. But working on that, and keep an eye on it.